0 is a nice one here. You guys hit -9 for the 3.
Yeah.
Okay. So kind of again going back to like making sure you guys understood what I was talking about with Becca in terms of time or like order. I can choose to go in any order I want as long as I'm consistent. So if I do -9 minus 0, then I have to do 3 minus 0. Or if I go the other way, 0 minus -9, and then 0 over 3. Just have to be consistent about it. So -9 minus 0 over 3 minus 0. I'm sorry, -9 over -3, or -9 over +3. So this will be a -3 as my slope. And again, going back to our graph, from 0 to 3, 0 down to 3 is way down here. That makes sense. You know, we're going downhill. Then from 3 to 5. Nice thing is we already know what 3 is. What'd you get for f of 5? 775. Ooh, that's a big one. And so, again, we're going from 3 up to 5. And if you look, it gets really big really fast. So really large numbers all of a sudden. So again, as long as I'm consistent, so if I do 75 minus a -3 over 5 minus 3.
It would be -9.
Oh, -9. Oh, thank you. Sorry, I was using my previous answer, but it wasn't the previous answer. Sorry, thank you. Okay, see what I did wrong here. So f of 3 is -9. I was using my slope from the previous one. Thank you. So this is -9 here, right? There we go. Thank you. So that ends up being 84 on top of 2, right? So 42 for our slope. So this one went downhill pretty steeply, but then this one went uphill like crazy steep. So just understanding kind of the average rate of change there. All right. So here's where they throw in these weird little symbols. And like, so they use that delta symbol again. This is called the difference quotient. So anytime they basically bring these deltas into it, like this delta t, if you're looking ahead at the problem, it's just another way to write this average rate of change. So I will write out this formula for us. And again, it's really kind of saying the same thing, just in a slightly different way. So hopefully I'll try to show you guys why it's there should be a little delta x there. Again, this is just another way to write the same thing. And I'll try to explain here in a second. I'll let you write it down and then. this is saying our starting value is x1. So if I started at 3, then it's saying the change in x. So taking my starting point and then adding the change in x. Well, the change in x is just the difference between those two. So like if I'm talking about 3 to 5, I just do 3 plus 2, which is 5. So essentially this is saying the same thing. This is really just x2. So like x1 plus the change of x is really just x2. It's just another way to write that. And then minus the starting value, like the outcome of the starting value. And then again, the change in x is just basically subtract the x's, x2 minus x1. So it's just another like fancy way to write this, but I want you guys just to be able to see how this kind of looks when we actually put this in this way. And I'll show you guys that this is going to be a little bit daunting when we actually like substitute this in. It's going to be a little bit annoying, so try to ease us into this a little bit. So it says find the average rate of change for the interval. So from t to t of or to t plus the delta t, which is kind of again strange, and I'll try to help us with this. So we're going to do h of t is just like this normally. Oops, I guess I don't need to write that again. Let's write it. So if I want to figure out what h, so I have h of t, and then I have t plus delta t. What we're going to do is substitute this in for t. So we're trying to write an equation that like substitutes that value in. So I have, I'm trying to decide if we should do this all at once, sorry. Because I have to take that and then subtract, I think we'll be able to do it. So let's do 960 t plus delta t minus 16 times t plus delta t.
Should that be squared?
Oh yeah, thank you. Squared. Now, do you want to like simplify this completely and then put it into the formula? Or do you want to keep going with our formula? What do you think? I'm trying to decide the most efficient way. I think maybe simplifying first.
Yeah.
Try that. Okay. Let's just focus on simplifying this first. Oops, no, I can't do that one. What do I have to do that's squared? Multiply it twice, not kill a puppy. Thank you. No puppy killing here. So we actually have to FOIL this. Oh my gosh, what's going on here? So we're going to FOIL that the t plus delta t. So we're going to FOIL this. I might need more space. So I'm going to write this twice. That's really ugly, that d delta t there. Or t delta t.
They use T.
I know,
They look
T is
like
so
plus.
bad. I know. I try to. That's why I make them like all kind of hooky, like so that t delta t. We need to write that as 2. have to distribute that 16 in. I'm totally out of space, and you guys probably are too, huh?
Like overall, because they're not like the actual stats in wrestling. You know what flow sports is, or like flow wrestling. Okay, it's basically like track wrestling. They release their rankings and they don't do it in individual divisions. Like they just do all like the whole state and have 9. Yeah. So yeah. And so I don't know what that means for division because I didn't like look at which division everyone was about because
All right, so this is now the simplified version, so simplified, of that first part of this formula. So all we've done so far is this. Ugh. All right, but now we need to subtract off.
wait, can you go back down to the I didn't write that down.
I distributed that negative 16. Oh, should this be a negative 16 here? Thank you. Negative 16. Anytime I hear you guys whispering, I know I did something wrong. Negative 16 there. So this was only the very first part of that. But now we look back to that formula, and now we have to subtract f of x off of that. So I'm going to do minus our f of x, so like our original function. So going back to the very original function. But I have to distribute that in, so I'm doing like the top of that fraction, that difference quotient. I'm sorry. This is rough. All right, so this is going to cancel here. I'll try to be a little more efficient here with my space. That's going to cancel. This is also going to cancel, negative, negative. So I'm left with, maybe you can write it up on the top or in the margin or something.
Wouldn't that be positive because you distributed the one here to another number? Oh wait, so it cancels.
Yeah, so that's why they cancel, right?
I was like,
All right, so I'm left with 960 delta t minus 32 t delta t minus 16 delta t squared. And we still need to put that over our change in t. What happens here is, since those are all being divided by delta t, we can cancel one of the delta t's out of all of those. So, looking at this would cancel here, but that would also cancel like here, and it would cancel one of those because there's double them. So the final product of this is 960 minus 32t minus 16 delta t. So after all that, that's what we end up with. Sorry, I should have left a lot more room. You guys are my guinea pigs, I apologize. All right, so it says now use your answer in part A to find the average rate of change of h from 10 to 20. Now again, knowing all of this whole difference quotient, I wish that we had just like not ever learned that and then just known the 10 to 20, we could have just done that to begin with. However, knowing that this difference quotient exists is going to be something we'll be comfortable with, hopefully. I think there's like one like this on our homework I don't think it's quite as bad. So what they're basically saying is from 10 to 20, we want to put that value in. And so in this case then, t would be 10. And what would delta t be? 10. Because the difference between them, right? So it starts at 10 and ends at, or it goes 10 further. So then we can put those values in there. That should be 10. So we're able just to substitute it in. Again, I would go back and take my average rate of change the normal way if I could, but this is trying to show that there's kind of a more efficient way. And if you were doing that a bunch of times, it probably would be helpful. So we get 480 is our average rate of change, right? All right. All right, so you guys want to flip it over there. All right, I think we're going to skip the formula for the average velocity. We'll go right to just finding the average velocity, because I think you guys would kill me if we have to do another one like that. So average velocity, that's again, actually this one might not be as bad, but I mean, I'm afraid to try it and then have you guys upset with me. So we'll skip the formula for this. We're just going to go average velocity from t4 to 12. So again, you can just substitute those values in and find that average rate of change. So basically you're doing h of 4 to h of 12 in this formula, and then finding our average rate of change there. I need to stop our video before it gets too long.